Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Hello, my name is Suzanne Miller. I'm a principal researcher in the Agile in Government Initiative at the SEI. I'm here today to introduce Dr. Thomas Scanlon, who works in our CERT division. He is a senior cybersecurity engineer over there. And today he's going to talk to us about application security testing, and we're going to have a marathon because there are 10 types. So we will talk about whichever ones of those you want our viewers to know about. But before we get started with that, tell us a little bit about your background and sort of how you came to be in this particular area of research.
Okay, hello. It's good to be with you today. It's a pleasure to talk about this. So working for an FFRDC, I get to work with a variety of government military programs. One thing I've been doing a lot the last few years is they want to increase their application security testing, and that leads to automating it, which is a lot of tooling. Mm-hmm. So I've been helping them bring tooling into their programs. And with a lot of these, just knowing where to start is a big obstacle. Sure. So there's a lot of options out there. So I've been helping them, pick through the options and what's appropriate, because what's appropriate one place may not be appropriate the other place. So we sort of go through, what fits in each context. Okay.
So when we talk about types of application security testing, what do we mean by types? So what are the different types of security testing that these tools support?
I put them into a group of 10 types of testing. That's just my designation. Sure. I've seen listings that have as many as 27 different types. For instance, the most basic one that people do is static code analysis. Mm-hmm. So those are tools that read your code, they have a copy of the source code, and they read through it and look for vulnerabilities and weaknesses. You can break that down into tools that look at source code, tools that do static binary code or bytecode analysis. Okay. So they look at the compiled code. So that's where you can differentiate further. But at the end of the day, it's a static code analysis. So the tool is at rest. It's not in a running state when you're doing this analysis. You may have the source code, you may have the binary, but you're doing tests.
So if you have a COTS product, for example, a commercial off-the-shelf product, you're going to be doing the binary. They're not likely to give you the source code.
Correct.
So there are cases in the government where we do use code that comes from other places. So that's an important aspect of being able to test the binary, not just the source code.
Yeah, and in the government in particular, you find cases where the contract between the government and the software producer only allows for delivery of executables. Right. They don't even get the source code. Yep. So then all you can do is testing on the binary. So that also leads to the next most common one, which is dynamic testing. So that is where you run the code and you do testing with the code while it's running. That is like black box testing. Mm-hmm. So you're going to run it, you're going to throw test cases at it, and you're going to see what happens, basically.
And so you're looking at test cases that are geared towards a security aspect, not just performance.
Yeah, so the tools do support some functional testing and security, so it's not always just security. Even some of the programs I work with, we're doing functional test cases and security. Right. But yeah, what you'll do is you'll throw test cases at it. A lot of times you'll do what's called fuzzing, where they throw known invalid test cases at it, and they want to see what happens. How does it fail? Does it fail gracefully? Is it resilient? Because a lot of times the weakness or the vulnerability comes about through not handling a failed test case.
Right.
So most software
or anomalous data.
Yeah, right. So a lot of software is pretty good at getting through the normal use cases. It's when you get into those nooks and crannies that things can go haywire.
So it would be easy to think that static and dynamic are the only two. You're either code at rest or your code being running. So what are some of the other types that are beyond the static and dynamic categories? Yeah,
so really I think there's principally three big types. So we talked about static, we talked about dynamic. The third one is what they call origin analysis or software composition analysis. And what these tools do is they look at all the components and libraries and things that you bring into your product to see if you're bringing in vulnerabilities and weaknesses into your product. And so what those do, they don't necessarily examine, say, source code. They're just examining like the software bill of materials or the manifest of what's in your software, and they compare that to a list of known vulnerabilities. For instance, the NIST, National Vulnerability Database, is a common one they look at. So they say you're using these components, and we know that there's vulnerabilities in those components, so you should either patch or upgrade or use a different component, or at least some way address that. So those are the three big types.
And that type is a newer type. I mean, I know I talked to a government group 15 years ago that was interested in exactly this type of origin analysis. And at that point, we basically said, well, there's not really any automated way to do this. So
Right.
This is actually a big step forward to be able to do origin analysis in an automated fashion.
Yeah, these tools have really grown recently. One of the hindrances to these tools in the past was that they involve a lot of data because you're basically cataloging, every
Sure.
software component out there and every known vulnerability, and those are continually updated, right? So there's new vols discovered every day or introduced every day. There's even for the systems that are out there that work really well now, they require a lot of data storage or a lot of traffic to do these
Sure.
comparisons.
A lot of bandwidth.
But the benefit is, one of your biggest exposure points can be known vulnerabilities. So, your software may have vulnerabilities that nobody knows about, so your risk of getting, exploited through those
Right.
is low. But if you're using known software components that have known vulnerabilities, adversaries are familiar with that. So those are ones you definitely want to patch.
Right, right. So in your research in these application security testing tools, is there advice that you would give to a program that's just starting to think about this? What is it that will make this journey a little easier? No, I'm not saying there's an easy button. I know there isn't. But what are some things that they should either be aware of, cautious about, or should be really looking forward to in terms of how they navigate this space?
So outside of doing some basic research and reading blogs and papers and things.
You have a new blog.
I do.
Yeah, I heard it's pretty popular too.
It
so,
is.
All right. So blogs are one of our favorite ways of learning things today.
So there's a lot of information out there. So besides learning the information, the biggest thing I say to do is just get a tool in hand and exercise it a little bit. There's a lot of really good open source tools in each of these classes. And there's also a lot of commercial tools have trial licenses and free licenses.
Right.
So before you rush in and think you need a certain product or commit to buying a big product, just exercise the tools a little bit and you'll learn so much about the capabilities of the things you're looking for.
Okay. Now, some of our customers have environments that are difficult to get tools approved. Do you have any advice for those kinds of environments? Are there pre-vetted, kinds of lists of security testing tools that people that are in constrained environments would be able to have easier access to?
So some of the commercial tools are on different approved product lists within different.
So that's a place they need to look.
So
what
they
are
wanna
the
look
approved products?
Yeah. So for instance, in the military, each of the services has an APL or the equivalent. DHS has a TRM. So you're going to look at those approved products lists. Some products will be on there. There's also a lot of products that are developed by FFRDCs and other researchers from the government.
Right.
So their approval's almost implicit. I mean, you still want to check with your authorizing
Your local
officials.
authorizing officials.
Correct.
Yes. Yeah.
But that's a good place to get tools and to get them, no cost to the tool itself anyway. So that's a good place to
First
start.
one's free.
Yeah.
Then you get involved in it, and then you end up. But that's okay. I mean, if it's useful to you, then that's what you want to do. Yeah. So there's so many tools out there. Are there particular drawbacks to using these kinds of security testing tools that people should be aware of? Any cautions that you would want to give people?
Yeah. So right off the bat, if you get one of these tools and you exercise them a little, like I suggested, you'll find out right away that the tools spew out a lot of output. And so that's the thing that I've seen programs get caught off guard by, where they did the right thing, they went and got the tools, they ran them.
Now what do I do?
And then they had heaps, literally, of output. And then I've actually been asked to help them go through the output and make sense of it. So be advised that you're going to get a lot of output. So for one, allow time in your budgets and your schedules for your developers and engineers to process that output.
Right.
Especially the first couple times through, it's not so easy. A lot of the tools have settings where once you've looked at an output or a finding, You can mark it to not come up again,
Right.
or mark it remediated, and it'll test it once, and then if it satisfies the test, it won't bring it up again. So there are mechanisms, but the first time it really is labor intensive to go through these tools and go look at all the output.
And one of the situations I've seen is that output is not sensitive to your context. And so there are things that it may warn you about that actually are okay in the particular environment that you're in, and the tool can't know that. It can't know that you have other kind of mitigating things happening around the software. So that's one of the reasons that you end up with a lot of warnings that you may actually not need to pay attention to directly, even though you need to make sure that they are mitigated in some other way.
Absolutely. So the first attempt to fix is usually to fix the code, right? But there's a lot of cases where there are other mitigating factors that you don't really need to fix the code. You just need to say that, document that this doesn't need fixed for this reason, and then you can suppress that warning from coming. The other thing is a lot of the tool findings produce like syntax errors, or they do like a linting, and it's more of a style issue that they find. So while it's good to write good-looking code, if you have a lot of priorities, competing priorities, it may not be that important to you. So you can suppress those warnings. So as you use the tool, you can find things you can suppress.
Okay. What are the most, so one of the things I know from other kinds of pipeline sorts of things, you're doing one thing and then another, and you're trying to get different kinds of testing done. What are some of the interactions that you find interesting between security testing tools and other types of automated tools, automated build tools, automated performance managers? Have you seen any issues or any interesting sort of factoids that come up when you put these tools into a pipeline with other tools?
Yeah, so one of the biggest decisions you have to make in those types of settings is if you want the findings or security tool to block your builds. So there's a lot of programs that run the security tool as part of the nightly build process or somewhere in their check-in process. And then the tool finds things. There's pros and cons to having it halt your build or halt your check-in. Obviously it slow the process and defeat the whole purpose of doing the DevOps or the Agile. On the other hand, if you just let the tool run and the findings get put aside to be dealt with later, then they don't get dealt with later. So typically what you see is they'll put a prioritization on the findings. And so a high-level finding can block a build, but everything else gets set aside. And then you really just need a good business process to say we're going to address the findings we set aside, once a week or whatever schedule fits in with your project.
So we talked about the sort of big categories. Are there any particular tools that out of the 10 types that you'd like to highlight as being something that our viewers may not have run into? So for example, I'm guessing that the origin analysis tools are new to people that haven't really been doing much with supply chain management. Are there any particular tool types that you go, you probably haven't seen this before, but it's important?
So I think the emerging space is there's a class of tools we call correlation tools. And what they do is they take the findings of multiple tools and correlate them together. So it's usually a good practice, once you get a tool introduced and running, to run more than one tool. Because we find there's studies that show this, that the intersection between two tools of the same class isn't as much as you would think. So if I run two different static code analyzers, they're going to find some of the same things, but they're going to find things that the other doesn't find. So it's sort of a best practice to run more than one tool when you can. A lot of times you achieve that by maybe running a commercial product and an open source product, so it fits in your budget. But when you have, I already said that you get a lot of output from one tool, then you run another tool, you get more output. So these correlation tools help you that you can address, when they do find the same finding, it'll correlate them together, you're not going to address it once. And it'll help you manage the output. So a lot of them have really good interfaces for triaging your findings and assigning the priorities. So that's an emerging class of tools. And with that is something they call application security orchestration. So that's where if you're going to run multiple tools, you'll have sort of a tool manager tool.
Oh, okay, okay.
So I'm
If I use these settings here, then make sure that those also get set over here and things like that.
Or make sure my static code analyzer tool runs first, and then I'm going to run my dynamic code analyzer.
Okay.
So there's some tools like that, sort of like tools.
So it's
of
the
tools.
automation of the automation.
Correct.
Oh, we're getting very meta here. This is good. This is good. Okay.
Yeah.
So open source security tools, everybody can access. The paranoid in me says, well, if I run open source security tools, am I actually exposing myself to bad actors who use the data about people using those tools in wreaking their havoc?
Yeah. So
is that a risk that I should be worried about, or am I just paranoid?
You should be conscious of that. So the security tool itself, if it's open source, you have the code, so you can run a tool on the different
Probably
tool.
Not a bad idea.
Right. Run it on there. Also, just using open source components in general, there's some aversion for that reason, because anyone can contribute, even if it's not the security tool, if it's just a library I'm using. The flip side of that argument, though, is because it is open and transparent, the more eyes looking at it, some people actually consider it safer because you have a lot of different people looking at it, that someone will find that.
And I imagine there are some white hat types of hackers that sort of specialize in, let me see what's going on with these open source security tools to make sure that they are safe for my use.
Correct.
So
yeah, and a lot of the open source tools do come out of, like I mentioned, government projects or foundations that are dedicated to open source software in general, that are trusted in the community, and they have their own vetting process for who can be contributors and how things get into the code base.
I'm feeling less paranoid now, thank you. I do have that streak, which is why I don't work in your field, because I would know, as the more I would know, the more I would just not be able to sleep at night. So I thank all of you who work in that field because you keep me out of it. So we like to stress in our podcast transition because if nobody knows, nobody can do anything. But what are some, besides the blogs and some of the writing that you've done on this, are there any other kind of transition mechanisms that we're using to help people get access to some of the tools that we may have used or may have developed? And how do people get to know more about this if they are new to this area?
Sure. So I've spoken at a couple of conferences where I've presented some similar material. We do have a software.
Are you going to be at FlowCon?
I am not.
Oh, man. All right. But we still like FlowCon, even though you're not going to be there.
We like FlowCon. This doesn't really exactly fit FlowCon. So I recently spoke at the ISC Squared Security Congress about application security testing tools. The SCI is hosting a software assurance conference in a couple of weeks where we have different creators of open source testing tools presenting. So you can come.
Is that going to be here in Pittsburgh? Or
it's in our Arlington office on November 27th. So that is open to the public, free registration. You do have to register, but it's free registration. There's going to be 5 or 6 people there that have open source tools presenting sort of the 101 on their tool and how you can use it, where you can get more information.
So this is an area where there's probably more information than you can digest rather than less, it sounds like.
Correct. And that was part of the motivation for the blog posts and things about putting the tools. So a lot of developers are familiar that there's tooling, and they know what to do when they get a tool report because it's their language. They understand the code, but they're not sure which tools to run and why, what fits their situations. So just sort of put your arms around it and get it into buckets on paper has been helpful to a lot of people.
Based on what we're seeing in terms of the hits on the blog post, I think a lot of people need that. So thank you for writing that blog for us.
Sure.
And I just want to thank you for talking today. This is an area, despite my paranoia, I have a lot of interest in how do we deal with all of these problems. So I really appreciate all of you that work in this area. So for those of you that want to know more, please look at Dr. Scanlon's blog post on application security testing, and some of the other resources that he's talked about we'll have posted on our website. And I want to thank you again.
Great, thank you.
Thank you for joining us. Links to resources mentioned in this podcast are available in our transcript. This podcast is available on the SEI website at sei.cmu.edu/podcasts and on Carnegie Mellon University's iTunes U site and the SEI's YouTube channel. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.